Alright, let's go over the test. Make sure you know how to do this. So, number one, I've typed that equation into my calculator, and I just typed it in, so now I'm going to take another quick look at it. It's so critical on this problem. You can waste so much time if you don't have it typed in correctly. So 2x to the fifth, 5x to the fourth, negative 23x to the third, negative, yes, negative 73x squared, plus 48x, plus 126. Okay, it looks like I've got it typed in correctly. Now, to get an idea of what the zeros are, I'm going to graph it. And it looks like I got something strange set up for my window. It looks like it's doing a bunch of jumping around here, so I'm going to go zoom 6, and then I may even go zoom 4. So, I notice no hesitations on any of the 1, 2, 3, 4, 5 zeros. They're all real because I can see it hit all 5 places. And there's 5 of them because it's degree 5. So there's no imaginary ones in this one. The first one I notice is this bounce, and it looks like it's at negative 3. Now to make sure, I'm going to go zoom 4. That looks a little closer at it. Still looks like it's at negative 3. And then I might even go zoom in and then move the cursor over to that negative 3. It's hard to see it in that video, but I'm moving the cursor over to right on negative 3 and then press enter again for that zoom in. And it does look like it hits right at negative 3. So I'm going to start with doing negative 3, and I'm going to say it bounced there. So my first guess is negative 3, a bounce, which means it should go in twice, multiplicity 2. And what I mean by go in, it should go in using synthetic division. So I'm going to put the 2x to the fifth. I do have x to the fourth, so 5 of them. And I do have x to the thirds, negative 28. I do have x to the seconds, negative 73 of them. I do have x's, 48 of them, and then the constant 126. So I didn't need to put any zeros in because I have all coefficients for every power of x. And I'm going to try negative 3. So, add 2 and 0 is 2. Negative 3 times 2 is negative 6. 5 plus a negative 6 is negative 1. Negative 3 times negative 1 is positive 3. Negative 28 plus 3 is negative 25. Negative 3 times negative 25 is plus 75. Added to a negative 73 is plus 2. 2 times negative 3 is negative 6. 48 and a negative 6 is 42. Negative 3 times negative 42 is 126. Negative. Adds up to be 0. There. Confirms that negative 3 was at least once. But we thought twice because it was a bounce. At least I did. And so I'm going to put the negative 3 into what I have. Because what I've learned so far is that x, in this part that says factor, x plus 3 is a factor. Now I'm going to try it again, and if it goes again, I'm going to be able to square this, which is what I think it is. The multiplicity is basically the power of the term. So 2 plus 0 is 2. Negative 3 times 2 is negative 6. Add those, I get negative 7. Negative 3 times negative 7 is plus 21. Negative 25 plus 21 is negative 4. Negative 3 times negative 4 is plus 12. 2 plus 12 is 14. Negative 3 times 14 is negative 42. And add it up in 0. which is what I wanted. So it does look like it goes in twice. Now I've simplified my problem a great deal. I went from a 5th degree equation to a 3rd degree equation. Now I could continue working with the same graph, or I could come down here and just turn that one off and come down and work with what I got left. 2x to the 3rd, because this is 5th degree. Dividing it by once, it makes it 4th degree. Dividing out another x minus x plus 3 makes it to the 3rd. So I get 2x to the 3rd minus 7x squared minus 4x plus 14. And I can graph that on Zoom 6. And I should see the other 3 zeros still. That one looks in between, that one looks in between. They all look kind of in between things. I got to pick something to go for. Now, we can let's just start looking at these. Let's go for the one right there, a little bit plus. Actually, let's go zoom 4. They're all close enough to 0 that I can zoom in a little bit there. Zoom 4. So none of those 3 look like they're going to be nice whole numbers. Clearly not whole numbers, not integers. So I'm going to take a look at the 0 here between 1 and 2. So I'm going to go second, calculate the 0 between 1 and 2, and it's about 1.5. And it says it's 1.414. That doesn't look like a repeating decimal. So I'm going to hold off on that one a little bit. I'm going to go check this one, because this one over here looks like it matches that one, only negative. So I'm going to go over and look at the one between 1, 2, 3, and 4. 3 and 4. Second, calculate the 0 between 3 and 4, and it looks like it's about 3.5. And it says, yes, 3.5 is a 0. Makes it come out to be 0. Well, 3.5, or 7/2, is that a possibility? Well, I look at the factors of 14, which are 1, 2, 4, and 1, 2, 7, and 14. And factors of 2 are 1 and 2. Is there any way I can get 3.5 out of this? And 7/2 is 3.5. So I can do 3.5 or 7/2. Actually, 7/2 would be easier, but I'll do 3.5 because some of you totally resist fractions. So I'll bring down the 2. 2 times 3.5 is 7. Negative 7 plus 7 is 0. 3.5 times 0 is 0. Add these and I get negative 4. Negative 4 times 3.5 is negative 14. Add them up and 0. So it goes in evenly. So now I know that 3.5 or 7/2 is another 0. The graph goes straight across, and even the original graph went straight across, so it went straight through. So it has multiplicity of 1. And now the good news is I'm down to a quadratic. So I can use the quadratic formula. Oh, let's get the factor in here. So I've got x minus 3.5 or 7/2. Okay, so now I'm down to 2x squared minus 4, and I'm trying to get that to equal 0. So I'll just set it equal to 0. And I can use the quadratic formula, but this one doesn't even have a middle term, so I can add 4 to both sides and get 2x squared equals 4. Divide by 2, x squared equals 2. Take the square root and I get x equal to plus or minus the square root of 2. Now let's go back to here and see if that is the square root of 2. Now let's remind ourselves what that number was. Second, calculate the 0. Oop, that was down here too low. There's my math on that. So let's calculate the 0 at between 1 and 2. 1, enter, 2, enter, 1.5, and it said 1.41421. Second quit. Square root of 2 is 1.4141421, which matches. So now I can give the other roots. In fact, I know they're in both these, so that's a plus the square root of 2 and minus the square root of 2. Each one happens once because it went straight through. And that's all I have to have here for that. That means these last factors are x minus the square root of 2 and x plus the square root of 2. And this is all good except for this was 2x to the 5th, and this only gives me x to the 5th. So I need to multiply by a 2. And that finishes that one. Okay. Now let's go on to the not so challenging ones. What's the y-intercept? Well, if I put 0 in for all the x's, all of this drops out and I get 126. Y-intercept's a point. I put 0 in for x and got 126. There's the coordinates of the point. Determine the end behavior. Well, we had the graph. We know it's a 5th. It's a positive. So it starts down, goes up, wiggles, and then ends up. So you can draw a little bit of a sketch, or you can say starts on negative side is down, positive side goes to positive infinity, or starts down, goes up, or ends up would be fine. Any of those. Local maximums. Okay, so now I got to go back to my original graph, and so I'm going to push my y equal and turn that one back on by entering on the equal, and turn that other one off by pressing enter on its equal, and zoom before we saw it. So it went up, down, then went way up and down, way down and back up, and so we're looking for maximums. Well, there's a maximum right there, and it looks like it got up to 0. In fact, that's what we knew it was. So we have a local maximum of 0. It happens at x equal -3, but it's 0. That's the answer I wanted. And then looks like there might be another max between around 0 here. And so we need to look a lot higher. So I'm going to take my window and look higher in the y's, maybe 200. And do we see it go way up there and come back down? There it is. So let's find that max. It's between -1 and 1 for sure. Second, calculate the max between -1 and 1, and it's about 0, and it says, thinking, it happens at 2.855, but it's 133.14. 133.14 happening at x equal about 2.2855. But these are the numbers I wanted. When is this graph positive? So let's go back to the graph. Well, it's positive between these two zeros, which were the negative square root of 2 and the square root of 2. It's positive after this 3.5, it's positive. And it's also, it's not positive at -3, it just gets to 0. So it's positive from negative square root of 2 to square root of 2, and from 3.5 and above. And that's the answers for page 1.